Continuing from previous video of quadrilaterals, here we will discuss about parallelograms. Now, a quadrilateral becoming a parallelogram, there are 4 different possibilities where a quadrilateral will be a parallelogram. The first one, opposite sides equal. It means if the opposite sides of a quadrilateral are equal, it will be a parallelogram. How? Let's see that. Now it is given that this side is equal to this side and this side is equal to this side. So just to prove this is a parallelogram, we'll match this diagonal. If as a result there are 2 triangles now, this is the side BD is common in these 2 triangles and these 2 sides are equal to this. So using the congruency property SSS of triangles, these 2 triangles are congruent. If these 2 are congruent, automatically this angle, these 2 angles will be equal. And if these 2 angles are equal, AB and DC crossed by BD and these alternate angles are equal, automatically these 2 sides are parallel. Similarly, we can prove that these 2 sides are also parallel. So the sides are parallel, opposite sides are already equal, it is nothing but a parallelogram. So the case 1. Now we will come to case 2. In case 2, opposite angles equal. Means in a quadrilateral, if the opposite angles are equal, it's a parallelogram. Let's check this also. It is given that angle A is equal to angle C and angle B is equal to angle D. And what is the summation of all these 4 angles? 360 degree. Out of this, AC is equal to C and B is equal to D. It simply means twice of angle A plus twice of angle B is 360 degree. It means A plus B is 180 degree. Clear? So these two angles of one side are adding to 180, where AD and BC are 2 lines cut by AB. If these 2 angles adding to 180 degree, from the properties of parallel lines, AD is parallel to BC. Similarly, these 2 sides also can be proved they are parallel. So if if there are 2 set of parallel lines, it's a parallelogram. So second property also proved. Coming now to the third one. If diagonals bisect each other, and what the fourth property? Fourth property is one pair parallel and equal. So we'll take first property number 3, then property number 4. Property number 3 says diagonals bisect each other. So in case of any quadrilateral, if the 2 diagonals are bisecting each other, it means these 2 parts are equal and this part is equal to this. A, B, C, D. The moment diagonals are bisecting and these 2 angles being opposite angles are equal. Is it clear? So these 2 triangles are congruent triangles. The moment these 2 are congruent, angles equal, and AB and DC cut by line BD, ordinate angles equal, it means these 2 are parallel lines. Similarly, we can prove so ABCD is a parallelogram if diagonals bisect each other. If you have gone through isosceles trapezium so far, please don't get confused, because in case of isosceles trapezium, diagonals are equal, but they don't bisect each other. Please take care. So this is not the case here, just for your information. Case 4. One pair of sides parallel and equal. Let's draw a case. Assuming that this side is equal to this side, in the same time parallel also and equal also. So if AB and CD both are parallel, just draw a diagonal. If these two are parallel lines, if this one and this one, in this case, this angle is going to equal to this. Why? Just because of this line and parallel in the ordinate angles. So, taking from the property of SAS, sides equal, this side common in both the triangles, and the common angle is equal. So it means these two triangles are congruent. The moment these two triangles are congruent, this side is equal to this side. At the same time, because angles equal, so this line will be also parallel. As a result, the fourth case also proved, where if one pair of sides parallel and equal, it will be, or quadrilateral will be a parallelogram. So these are the 4 cases. In the meantime, what will happen if in case of a quadrilateral, if we match the midpoints, if initial quadrilateral is A, B, C, D, and this is P, Q, R, S, what will be the nature of this quadrilateral PQRS? In a quadrilateral, A, B, C, D, all these 4 midpoints matched, a quadrilateral formed. Now, this formed quadrilateral will be also a parallelogram. Why? What we can do, we can simply match this line AC. Now, because we match the AC, in a triangle ACD, these two sides midpoint S and R matched. So, from the property of triangles, if S and R matched, this line is parallel to base, in the meantime half of the base. So SR is parallel equal to half of AC. This is also known as midpoint theorem in case of triangle. Using the same, we can prove PQ equals to half of and parallel to AC using this one. So it means PQ parallel equal to half of AC. It simply means SR is parallel and equal to PQ. Now, the moment one pair of line parallel and equal, using the fourth property, quadrilateral became a parallelogram. Clear? So this way, a quadrilateral becoming a parallelogram